Have you ever noticed that the place where you learn mathematics is itself one giant mathematics problem? Every classroom, every hallway, every desk, every school bus, every lunch period, and every ringing bell exists because someone solved hundreds of mathematical problems before the first student ever walked through the doors. Schools don't simply teach mathematics, they are built with mathematics. Today, we are going to discover the hidden mathematics behind one of the most familiar places on earth, our schools. Welcome to Skitami Learning, and let's discover. Imagine your town is building a brand new school. How big should it be? Too small, and students won't have enough classrooms. Too large, and millions of dollars are wasted. Everything begins with one simple question: how many students will attend this school? Let's imagine our school has 600 students. Okay. And suppose that every classroom comfortably seats 25 students. Per classroom. So, simple math. So it's going to be 600 divided by 25. That gives us 24. So this school will need 24 classrooms to comfortably seat 25 students in a student population of 600. Now, what happens if we build only 20 classrooms? It will work, but you'll have a cramped classrooms. Instead of 25 students per classroom, you are going to have more in the classroom, which is not going to be efficient. Now, what happens if we build 50 classrooms? Nothing wrong with building 50 classrooms. You'll have enough classroom, but it will be a lot of empty rooms because the student population is only 600. You can still fit in there, but if you have many teachers, which is not very easy to get nowadays, then you can have a classroom with multiple teachers with less students in each classroom. But yet, we want to be realistic. So 25 students per classroom is the average. So that's pretty much the way it will be done. So 24 classrooms is what will be needed to accommodate 600 students. Okay, that is mathematics shaping an entire school. Now, let's talk about the hallways, which is the center or the heart of schools because it connects multiple rooms. Let's say you have a school like this, just a simple representation. Okay. Then you have classrooms, and this is the hallway. How wide should this be to accommodate the students? So this is a classroom. This is also a classroom. And so forth. All these are classrooms. At first glance, it always seems simple. But hallways are really geometrical problems. Imagine 600 students walking through here. This hallway. Okay. And they only have 5 minutes to go from a classroom to the another one. Architects must calculate the hallway width so students can move safely without creating dangerous congestion. There will be traffic of students going this way, going that way. So would a hallway have only 3 feet? So 3 feet? Probably not. Would a hallway have 100 feet? Probably not. It's too wide. So the right answer is going to be somewhere in between. Mathematics provide the safest and most efficient solution. Every hallway you have ever walked through is a result of geometry. Let's look at the giant scheduling puzzle. Let's say at 8 a.m. we have our favorite subject, mathematics. At 9 a.m. we have English. At 10 a.m. we have science. And 11 a.m. we have history. Then we have lunch and PE. Okay. Now think about everything happening behind the scenes. Our school has 600 students. So 600 students, 30 teachers, 24 classrooms, and 6 class periods. Every teacher must have a classroom. Every student must attend the correct class. No two classes can occupy the same room. Teachers also need planning periods. Lunch period must fit. Special classes must fit. Creating a school schedule becomes one enormous mathematical puzzle. In mathematics, this is called an optimization problem. Today, computers help schools solve scheduling problems that will take humans weeks to organize. Okay. Next, let's attack the mathematics of school buses. So let's say this is our school. Okay. You have one house here, 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 one house, one house, one house. Just a rough sketch. Should a school bus simply drive around randomly until every student is picked up? Of course not. School districts try to pick up the greatest numbers while driving the fewest miles, using the least amount of fuel, and arriving at school on time. Every stop adds time. Every unnecessary mile costs money. Finding the best route is another famous optimization problem. The same mathematical problems is used by a large company, ground operation that operates on the ground and in the air or even at sea. Every morning, school buses quietly solve mathematics before even students arrive at school. So, looking at this puzzle here, what is the easiest way, the most efficient way to get students to school in a timely manner? So let's look at a small optimization problem. So a school bus leaving this house here, coming to this one, coming to this one, coming to this one, coming to that one, coming to that one, and arriving at school. Okay. This one can do this way, come that way, come this way, come that way. Or another option is this way, that way, that way, that way, and school. And then you can have another one going this way, that way, that way, that way, that way. All of these are leading to schools, and optimization is key here to make sure that every student make it on time. Lunch is another issue that school face every day. Let's assume that you have 600 students. Okay, 600 students, and the cafeteria can only hold 200 students at a time. Cafeteria. Okay, So what would happen if all 600 students at 12 noon arrive at the cafeteria? Okay, what will happen? The students will not fit. It will be complete chaos. So schools solve this using mathematics. Suppose so 600, just to make it easy, 600 is easily divided by 200. So that's about 3, right? So in order for all these 600 students to fit in the cafeteria, they will need to have 3 lunch periods. Okay. So 3 lunch period to have the 600 students in the cafeteria that can fit 200 students at a time. Without it, it will be complete chaos again. So school needs to have a reasonable amount of lunch break of 600 students accommodated. Let's talk about one of the most versatile places in the school, the gymnasium. Okay. A gymnasium is a place where you can have multiple things, either at the same time or at various times during the day. You can have a basketball court, can be a volleyball court, it can be bleachers, it can be a stage, or it can serve as storage. Now, a gymnasium is very versatile. During the morning, it can accommodate any of these things. In the afternoon, it can accommodate any of them again. And another day, it is transformed into a wrestling venue. Sometimes graduation ceremonies take place here. Community meetings sometimes, science fairs, robotic competitions, school dances, even emergency shelters during severe weather. The same room serves many different purposes. That doesn't happen by accident. Architects use mathematics to determine the floor dimensions so multiple sports can fit inside one space. They calculate ceiling height, lighting, bleacher capacity, walking spaces, and emergency exits. Every inch must satisfy multiple uses. One room, many purposes, all made possible by mathematics. Let's look at another really versatile area in the school, which is the auditorium. Why are seats arranged in row? Why isn't every chair placed randomly? Because mathematics help every audience member see and hear the performance. Architects calculate the angle of the floor, the spacing between rows, the height difference from one row to the next, and even how sound travels through the room. The ceiling and walls are carefully shaped to reduce echoes. The stage lighting is positioned using geometry. The speakers are placed using angles and distance calculations. Whether you are watching a school play, a concert, an award ceremony, a graduation, you are experiencing mathematics in action. Without geometry, many people couldn't even see the stage. It's time for today's DMV challenge. Suppose you have 840 students. Each classroom seats 28 students. How many classrooms are needed? $840 divided by 28, it's about 30. Now here's your challenge. Suppose enrollment grows to 980 students. how many classrooms would you need to accommodate that surge? Don't tell me. Write the answers in the comments below. Let's see who gets it right. To conclude, today we discover something remarkable. Schools don't simply teach mathematics. They are built, organized, and operated using mathematics every single day. Arithmetic determines classroom capacity. Geometry designs hallways. Optimization creates schedules. Networks plan school bus routes. Patterns organize classrooms. Statistics help schools prepare for the future. The next time you walk into a school, look around. You'll discover mathematics everywhere, long before the teacher even begins today's lesson. If you enjoyed today's episode, please subscribe to Skitami Learning. Share this video with one person who has been to school, which is just about everyone, and leave a comment telling me what everyday place or object would you like us to explore. Thank you for watching, and remember, mathematics isn't hiding inside textbooks. It's hiding all around us. I'll see you in the next episode.